This experiment is called as least disk experiment for finding the thermal conductivity of a bad conductor. This is the bad conductor which is cut in the shape of a cylinder with a small thickness. The thickness is small d. We can measure the thickness of the bad conductor by using the screw gauge. The apparatus that are required for doing the experiment is that a hot plate is required, a steam chamber is required, a rubber tube, then here we are having a upper chamber and there is a lower chamber, cylindrical metallic disc. Thermometers, 2 thermometers are required, stop clock is required, the screw gauge and vernier caliper are required. So these are the instruments that are required. Now how to do the experiments? Initially we are heating the hot plate. The temperature of this steam chamber is going up to the boiling point of water. Now the steam comes through the upper chamber and the steam would be reaching through this outlet. You can insert a thermometer in the hole that is provided here and you can note down the temperature and it reaches a maximum temperature. It is called as the steady state temperature of the upper disc. This is theta 1. Steady state temperature of the upper disc is theta 1. The bad conductor is placed in between. Here there is a lower metallic disc. The bad conductor will not conduct. So the conduction is very poor. So even if it is at 100 degrees, this will not be increased to higher temperatures because it's a bad conductor. This will be around 40 or 50 degrees. But whenever it reaches the steady state and when the time increases, the bad conductor also will start conducting and the lower metallic disc is increasing. But this temperature will be reaching a particular value and it cannot reach 100 degrees, but it can reach up to a certain value called as steady state temperature of the lower metallic disc, which can be noted by the thermometer. The steady state temperature is theta 2. It is the maximum temperature. For 5 to 10 minutes the temperature cannot be increased beyond that value. It is called as theta 2. Now what we have to do is that we have to remove the bad conductor and you have to keep this upper chamber onto the metallic disc directly. So when you are keeping it directly, this is at 100 degrees, this is at 70 degrees for example. Now this temperature of the lower disc will go on increasing because they are kept directly. Both are bad conductor, both are good conductor. The bad conductor has been removed. Now the temperature of the lower disc will be increasing. You have to allow this lower temperature to be increased by 10 degrees. So it has to be increased to theta 2 plus 10 degrees. When it is coming to theta 2 plus 10 degrees, you remove the steam chamber and you keep it away from it. Initially this was also removed. Now only the lower metallic disc is there. Now this will be cooling down. It is radiating from the top surface, bottom surface and the circumference. Now the temperature will be falling down. You have to wait with the stop clock until the temperature is coming 5 degrees above the steady state. When it comes to theta 2 plus 5 degrees, you start the stop clock. When you start the stop clock, then the time taken for the theta 2 plus 5 degrees is 0 seconds. And when it is falling by 1 degree, that is theta 2 plus 4 degree, if it is the temperature, note the time taken and enter it in the observation notebook. Then again 1 degree fall, the stop clock is run continuously and when it is coming theta 2 plus 3, again note the time taken. Similarly, theta 2 plus 2, theta 2 plus 1, theta 2 and theta 2 minus 1, theta 2 minus 2, theta 2 minus 3, theta 2 minus 4, theta 2 minus 5. So above the steady state 5 degrees, below the steady state 5 degrees, you have to note the time taken continuously by using the stop clock and every time note the values. Now you have got the values, that is the temperature versus the time taken. A graph is plotted between theta and the time taken. Theta is the temperature, T is the time taken, and after drawing the graph you will be getting a curve. Okay, now you have to draw a slope onto the curve at the point of the steady state theta 2. And if you get a point and if you get a slope 1 degree above the steady state theta 2 plus 1 and theta 2 minus 1, you draw a perpendicular line and you will be drawing a horizontal line. That will be d theta, and this would be dt. So d theta by dt is the rate of cooling by using the least disk apparatus, and you can be able to use this vernier caliper to measure the diameter of the metallic disc. So you have to measure by using the vernier caliper. At 5 different places you measure the diameter of the metallic disc. Okay, so if you measure the diameter, you can be able to calculate the radius of the metallic disc. Then you can use the screw gauge to find out what is the thickness of the bad conductor. So this is the thickness of the bad conductor. This also measured. Then use the screw gauge to find the thickness of the metallic disc. So by keeping at 5 different places, we can measure. Okay, so all the values are available now. You know what is theta 1, that is the temperature of the steam chamber, steady state temperature. Theta 2 is the steady state temperature of the lower metallic disc. Then you are finding out this thickness is h, and this thickness is d, and the radius of this bad conductor is r, and d theta by dt is the rate of cooling. From all these values, if you are substituting in the equation, you would be able to calculate what is the thermal conductivity of the bad conductor. The bad conductor we have used is the cardboard. Okay, thank you.